Hi, welcome to Tau versus Pi Class 1, passionate about mathematics. Historical mathematics claims the use of exterior angle property to prove the sum angle property of a triangle. One thing to observe is Euclid, or correctly speaking, Euclid of Alexandria, had some room for non-Euclidean geometry that came way after, somewhere in the beginning of 19th century. A close peep into his writings reveals that he always talked in terms of inequalities. Like for instance, he said, for any triangle when one of the sides is produced, the external angle is greater than each of the internal and opposite angles. But we derived it as exterior angle is equal to sum of interior opposite angles. Or for that matter, sum of two angles taken together in any possible way is less than two right angles. And again, we derived it as angle A plus angle B plus angle C is equal to 180 degrees. In any triangle, the greater side subtends the greater angle, and so on. So many of them. The idea is non-Euclidean geometry is an extension of Euclid's geometry. Let's learn it the original way, the original proof to some angle property. Alright, now for the Euclid's proof, what we require is we require the triangle ABC and we extend the side BC to the point D such that my exterior angle here is ACD. Look at the point E, which is the midpoint of AC. Join it as BE. BE is being joined and extending it to the point F. You can see the two colored triangles over there. Are the two triangles congruent? Oh yes, they are congruent. What is the criteria of congruence? Can you think of it? Very good. These are the vertically opposite angles, right? This is the sides. By construction, they are equal, and already we said E is the midpoint of AC, so obviously the two sides are equal. Alright, now what we have exactly proved here is we have proved that this part of the exterior angle is equal to the interior opposite angle A. What about the second part? This part, which is like FCD. How can we prove this part equal to the angle B? This is something which is thing sum, for which we have located the point G as we did here, point E on AC. Similarly, I've located the point G on BC, and I try and construct the two angles. Yes, you can work it out, try it out yourself. Right, so you can just look at the two triangles, and what I'm observing is this angle and this angle are equal. Again, we do it by the same method of congruency. So the exterior angle ACD is greater than either of the interior opposite angle, and to be exact, as we read it, it is the sum of two of them. The original way.